Okay, so welcome to us channel. Here is 2026 Hypatia problem 3. This question mainly uses the Pythagorean theory, property of tangent, listed here, and some basic algebra. Okay, let us get started. First of all, to do this question, we have to read the fact 1 and fact 2. We will use them in the problem below. Okay, in the first question, it provided a small circle centered with A and radius 10, another circle B, center B and radius 36, and we're looking for DE. So this means here, here we know BD, the circle center B is with radius 36, and center A1 is 10 and 10. And right now we're looking for the value of this one, ED. So this one is really simple. We just need to do 36 times 2 minus 10 times 2, and we get 52. It's our first answer. Second question. In the figure 2 below, a small circle with center G and radius 12 is drawn inside a large circle with center F, radius 49. The two circles are internally tangent to one another at K. Diameter HI of the large circle is tangent to the small circle at J. We're looking for the length of FJ. Okay, so in this case, we use both property at fact 1 and fact 2, where the lines through the center of two circles that are tangent to one another pass through their point of tangency, and a line tangent to a circle is perpendicular to the radius drawn to the point of tangency. Okay, the fact 1 is used when we're looking for this one, when we're connecting F to K. We know in order to let them be tangent, the line have to pass through F, J, and K, G and K at the same time. So this means this is a collinear. And this means HF, the radius, is equal to FK, which is 49. And then, since Fi is tangent to the circle center at G, which is like this, as a fact 2 said, GJ is perpendicular to line Fi. So right now we can form a right angle triangle. And right now we can just apply the Pythagorean theory. Then we can find the value of Fg, which is what we're looking for. So the next step is really easy. We just need to do 49 minus this part 5 minus, no, not 5, is 12. Minus 12 bracket square minus 12 square, the square root. And after some calculation, we will find the answer is 35. And this is our second answer. Okay, for the C, so it's just an application of the previous two questions together. So we read the question first. We're looking for the value of R, which is the radius of circle center at Y. So here's Y, R. and a small circle with center x and radius phi is drawn inside the large circle with center z and radius 18. So this is 18, and this is 5. And these two circles are internally tangent to one another at L. So since we see the internally tangent, we know there might be some similarity between this one and this one. The question 2-1 and the question 3-1. Okay, the diameter UV of the large circle is tangent to the small circle at M. Tangent. Okay, for sure these two are similar. And diameter and the medium circle with the radius are blah 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 blah. Okay, we can start it. So for this question, since we're trying to apply the thing we know in the question 2, in the question 3, the first thing we can do is trying to see the similar circle, the circle center at X and circle center at Z, to find this distance, and then we can find this distance. So what can we do is we draw the line and this one. So right now it's easy to see how this works. So we just need to do 18 minus 5 bracket square minus, and here is 5, so minus 5 square root. And after some calculation, we can get our answer is 12. So MZ equal 12. Okay, so this means since UZ, this part, is equal to 18, and UZ is equal to UM plus MZ. This means UM is equal to 6. So 6 here. UM. Okay. Let me write it here more clearly. So here 6, MZ is 12. And this is R. Okay. Then we just, based on the fact 1 we know, if two circles tangent to each other, the line connect tangency have to pass through their origin. So when we connect X, N, and Y, they for sure should be on the same line. And then we can do the same thing as the first step. We connect X and M to create a right angle triangle. Then we can create an algebra system that's including R, and then we just need to solve the R, and we find our answer. So what can we do is, based on Pythagorean theory, we know the value of xy is equal to, this is R and this is 5, so R plus 5, and the value of xm is 5, that we know 5, and for the value of my is equal to the diameter uv minus minus yv. So we substitute the value into it. So uv here is 18 times 2, 36, the diameter, minus 6 minus r. So this becomes 30 minus r. and then we combine these three together to form our system, where r plus 5 bracket square is equal to 5 square plus 30 minus r bracket square. So cancel out the r square, and we have 10r plus 25 equal 25 plus minus 60r minus 900. So 25 go, 900 to the other side. Wait for a moment. Let me see. Yeah, here is plus. So 60r to the other side. So 70r equal 900. So r, you find our value, which is 90 over 7. So this is our third question answer. To conclude this question, basically we're doing the same we did in the question B twice. We first use the method in the question B, find the value of mz and um. And then based on the fact 1, we know the point x, n, and y are collinear. So we're connecting the x and y and use the xm, line xm, and line xy, and line my to form another right angle triangle. After that, we use the Pythagorean theory. List an expression contains variable r. We solve it to find the value of r. In my opinion, the question C's hardest part is to find a pattern between the question B and the question C. If we find the pattern, it's really easy to solve. And the second thing, it might be a little bit challenging, is having the courage to decide spending time on listing an expression that including variable, which could potentially doesn't have anything in return. But in my opinion, it's always worth a try when you don't know what your next step is in the question like this.